Hi, I'm Mrs.D. Math. Thanks for joining me today. We're going to be exploring triangles in 6th grade math. So let's go ahead and get started. We're going to start with looking at triangle side lengths. And we're going to be able to determine if it is or is not a triangle based on the lengths of the side lengths. So let's look at a couple of different triangles here. And one of them is a 3, 4, 5 triangle, and the other one is a 3, 4, 7 triangle. So we want to decide, is this going to actually be a triangle or not be a triangle? In order to determine this, we have to follow the instructions here. And we know that the sum of two side lengths has to be greater than the third side length. So let's go ahead and test this out. We can say that 3 plus 4, is that greater than 5? And I can tell 3 plus 4 is 7, and 7 is greater than 5. Then I want to test out 3 plus 5, is that greater than 4? 3 plus 5 is 8, and 8 is greater than 4. Then I want to add 4 plus 5, is that greater than 3? 4 plus 5 is 9, so that is greater than 3. So this one is in fact a triangle. For this next one, let's go ahead and say 3 plus 7, is that greater than 4? 3 plus 7 is 10, and 10 is greater than 4. Then I'm going to add 4 plus 7 and decide, is that greater than 3? 4 plus 7 is 11, that is also greater than 3. Then if we add the last two side lengths, 3 plus 4, is that greater than 7? 3 plus 4 is 7, which means this is not greater than 7, so this one is not a triangle. So the information means it doesn't matter which two sides you're adding up. Any two sides, when you add them up, have to be greater than the third side in order for it to be a triangle. So what happens is this one, because 3 plus 4 is not greater than 7, the triangle would not end up closing. Let's look at some more examples here. So we have 9 plus 13 plus 18. And the thing that is easiest to think about is if you start with the smaller two sides and add those together, if they're greater than the largest side, then the other ways will work as well. So you can see here that when I add the two smaller sides for 3 plus 4, that was greater than 5. When I added the two smaller sides, 3 plus 4 was not greater than 7. So you can tell just basing on the smaller two sides added up to be greater than the largest side. So we're going to start here by adding 9 plus 13 to determine, is that greater than 18? 9 plus 13 is 22. 22 is greater than 18, so this is a triangle. Then we have 13, 20, and 35. I'm going to take the two smaller sides. 13 plus 20, is that greater than 35? Well, 13 plus 20 is 33, which is not greater than 35, so this one would not be a triangle. We're going to test out one more. So I have 12 plus 15, is that greater than 27? 12 plus 15 is 27. That is not greater than 27, so this one is also not a triangle. So if the side lengths are not large enough to be greater than the third side when you add them up, then it would not form a triangle. Now let's look at the angle measures of a triangle. So this one says the sum of the measures of the angles in a triangle is 180 degrees. So here's a formula for you. You can say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to equal 180 degrees. And I know this because there are only 3 angles in a triangle. So using this formula, let's see if we can figure out the actual degrees of the angle that is missing. So it is marked by a question mark. When we fill in our equation here, we're going to put in an X for that question mark. So we're going to say 60 is angle 1 plus 75 is angle 2 plus X, because I don't know what this question mark is going to be angle 3. Those have to add up to 180 degrees. So the easiest thing to do here is to add the two angles that I already know. And I can see that this is 135 plus x equals 180 degrees. So now, in order to find this missing number, x, I'm going to have to subtract my 135 from 180 because I know that whatever added to that equals 180 degrees is my missing amount. So now I can see that x is going to equal 180 minus 135, and that's going to be 45 degrees. So this angle that's missing should be 45 degrees, but I want to go ahead and check that. So I'm going to go ahead and plug 45 back into my original equation. And when I add this all together, 60 plus 45 is 105, and 105 plus 75 does equal 180 degrees. So that does check out to be the correct answer. In this right triangle, we know that this angle right here is 90 degrees because it is marked with a right angle measurement. So now I'm going to plug this into my equation. I have 90 plus 50 plus, I'm going to go ahead and use x again. You don't have to use x for the question mark, but that is a very common letter, and it's going to equal 180. So again, I'm going to add my 90 plus 50, and I know that equals 140, plus that missing value equals 180. And again, I need to find that missing value. So 140 plus what equals 180, and I'm going to work backwards to figure that out. So now x equals 40 degrees. Again, I can go ahead and plug that 40 back into my equation, and I know that 90 plus 50 was 140, and 140 plus 40 does equal 180 degrees. So this missing angle here is 40 degrees. Let's test out a third triangle. This one's a little bit different. It has two missing angles. And I can tell because they are marked identically, they might also include the same mark on the side lengths to indicate that those are the same angle lengths. So I know now that 100 plus x, my missing number, plus another x, because these are the same measurement, equals 180 degrees. So I'm going to go ahead and simplify this a little bit differently because now I have two x's. So that's going to end up being 100 plus 2x equals 180 degrees. And in order to get the 2x by itself, I know it's going to be added to 100, so I need to work backwards, subtract that 100 from 180. That means 80 equals 2x, and I know that 2 times a number has to equal 80 degrees, so that number is going to be half of 80, and half of 80 is 40, so this should be 40 degrees. So we're going to plug that back in. So if I put a 40 in for both x's, I can see that 100 plus 40 is 140, plus another 40 does equal 180 degrees. So my missing two angles are both 40 degrees. Now let's look at triangles and the relationship they have based on the side and angle measurements. So this first one says that the longest side is always opposite the largest angle. That tells me that this side length, which is the longest of the 3 side lengths of the triangle, is opposite from the largest angle. You don't have to know the degrees, but this will always be the relationship. Then it tells me that the shortest side is opposite the smallest angle. So that tells me that I know that this is going to be the smallest angle. Another thing we can look at is the name of triangles based on these side lengths. And this one has 3 equal side lengths. So that means it has 3 equal angles. And in that case, it is called an equilateral triangle. A lot of times you're going to see some sort of a mark either on the side lengths or the angles to indicate that they are equal. And the third one we have here is called an isosceles triangle. We've actually seen one of these already in the video. And whenever you have 2 sides that are congruent or equal, that means the opposite angles from those side lengths are also going to be equal. Then we know it is an isosceles triangle. Sometimes they will mark them like a previous example with the same measurement. In that case, it was the same question mark for both. Or they might mark the side lengths or the angles like we've done here. The last thing we're going to look at is how triangles are named based on the degrees of their angles. The first one we have is an acute triangle. So an acute angle, you've probably already learned about, is less than 90 degrees. So if all three angles of the triangle are less than 90 degrees, then it is called an acute triangle. An obtuse triangle has one angle greater than 90 degrees. So you've probably already learned about obtuse angles. If one of the angles is larger than 90 degrees, it is an obtuse triangle. That does mean the other two angles have to be acute, because you can't have more than 90 degrees and it add up to 180 like we saw earlier, but only one angle has to be greater than 90 degrees. The last one is a right triangle. So we know a right angle is equal to 90 degrees. So if you have one angle that is equal to 90 degrees, then you have a right triangle. The other two angles have to be acute, because again, you can't have two 90-degree angles and have three angles that add up to 180. So those are the rules on the right triangle and the obtuse triangle. They can only have one angle that's either greater than or equal to 90, whereas the acute triangle, all three angles are going to be less than 90 degrees. I'm Mrs. D Math. Thanks for joining me today while exploring triangles in 6th grade math. Have a great day. Bye.